This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
This chapter deals with what we call measures of average and dispersion, and I will break it into two lectures so it doesn't go on too long. In this lecture I'll look at measures of average, and in the second lecture I'll explain what we mean by dispersion and look at measures of dispersion. But first of all, average. And the point is we may collect data about something and want to know what the average is. For example, if you look under paragraph 2, frequency distributions, where it says discrete variables, I may want to know on average how many complaints do we get per week about whatever we're supplying. And it says we've recorded the number of complaints per week over the last year and produced the following table. So it turns out the complaints per week, some weeks were 0, some weeks were 1, some weeks 2, some weeks 3. So that's the number of complaints. And how many weeks did we get each of those, or what we call the frequency? In 12 weeks of the year, there were no complaints at all. In 16 weeks, there was 1 complaint. 20 weeks, there were 2. 4 weeks, there were 3. So there we are. Does it add up? Better check. Yeah, 52 weeks. So that's how many complaints there were per week. And shortly, we'll be interested to know, on average, how many complaints. Well, there, the number of complaints, it's always going to be a whole number. It's 0, 1, 2, 3, and it turns out they're never more than 3, so it's a very small table. And we call those discrete variables. In that the number of errors, it will be 0, 1, 2, or 3. Fine. But other situations, it may not be quite so, what you might call, simple. Look at the second one, the second table. We've recorded the total amount paid to employees each week over the last year and put as a table. Now our employees per week, we've got hundreds of employees and they paid anything between 0 and 3,000, and of course they could all be paid different amounts. And to do a whole list, we had the number of errors was 0, 1, 2, 3. To list every single pay per person, the list could end up being enormous. One person's paid 200, another person's paid 250, another person's paid 1,242, and so on. And so for something like that, we're more likely to set it up as what we call continuous in ranges. And so you can see how we've got the amount paid. Instead of listing each individual amount, we've taken it as 0 to 500, 500 to 1,000, and so on. I don't need to copy out the full table. And we said, well, the frequency, how many people are paid from 0 up to under 500, so 499.99. There's 1 person. 4 people were paid 500 to 1,000. 8 people were paid 1,000 to 1,500, and so on. Now, before anybody starts complaining, we do have to tie the ends up properly. I mean, if somebody's paid 500, we don't record them there and there. So as I did say, the first one would actually be anybody paid from 0 to 499.99. The second one would be anybody who was paid from 500 up to 999.99, and so on. But we're not really worried about 1 cent. And so to 2 different ways of setting up the table. This is continuous. The first one discrete. So continuous when we're doing it in ranges. Now, no big problem, except, as you'll see, it does slightly affect the way we go about calculating the averages. Before I come to that, let me, well, partly remind you and partly add. Two ways of actually presenting data, particularly when it's continuous. If you turn over, the two ways are what we call the histogram and the ogive. And so you've got a table there, which I'm not going to copy it all out. Well, I will, I'm sorry, because of something that's coming. Again, 0 to 500, there was one person, or 1 week, I'm sorry. 500 to 1,000, that's how much we paid in 4 of the weeks. 1,000 to 1,500, 8, 1,500 to 2,000, 19, 2,000 to 2,500, 14, and 2,500 to 3,000, 6. And so again, we've looked at 5, 13, 32, 52 weeks. And there's the total paid. You know, in 1 week we paid between 0 and 500, in 4 weeks we paid 500 to 1,000, and so on. Now, two ways you should be aware of in which the data can be presented, because it's nicer to look at it, easier to look at a table than, sorry, a diagram, rather than just look at the raw numbers. The first is a histogram, which is, now forgive me, I'm not going to draw it perfectly, and you won't be asked to draw one in the exam, but you're expected to know what one is. A histogram is where we do bars, the height of the bars depending on the frequency. So here the frequency, well, the highest was 19, the lowest was 1, so if I go up to 20 there, 10, 5, 15, and we were going between 0 and 500 up to 3,000. So 1,000, 2,000, 500. So I'm not going to try and be perfect here, and you won't be asked to draw one in the exam. But just to present that as a diagram, 0 to 500 occurred once. So 0 to 500, we draw a bar 1 unit high. 500 to 1,000 occurred 4 times. So 500 to 1,000, a bar 4 units high. 1,000 to 1,500, 8 times. I think by now you can see what's happening, but I'll quickly finish it. 1,500 to 2,000 is 19 times. Whoops. Oh. 2,000 to 2,500 is 14. And 2,500 to 3,000 is 6. So that's all the histogram is. And there's no extra information there, but drawing it as a diagram, I don't know, oh dear, does make it more immediately obvious. You know, the most common is there. It tails off on both sides. Now, I will, in fact, come back to histograms in the next chapter, where the idea of them is rather more important. But regardless, I hope it's clear what it is, what it's showing. The other way, or another way of representing the data as a diagram, less common, and again I'll explain why it might be useful later, is something called the ogive. Or ogive. And what we do here, again, it's going up to 3,000, so 0, 3,000, 1,000, 2,000, 500. And in total, the frequency, in total, there are 52 weeks. So this bit goes up to 52. And what we do is this. we say, okay, how many people earned 0? That's where we start. How many people earned up to 500? Well, one person. So I will split this up. There's about 25. Whoops. 30, 40, 20, 10. All right, so one person is about there. So up to 500, there was one person. Oops. How many people in total earned up to 1,000? Well, one person earned up to 500. Another 4 people earned 500 to 1,000. So in total, 5 people earned anything up to 1,000. So 1,000, 5 people is there. Uh, 1,500. How many people in total earned anything up to 1,500? Or how many times, I beg your pardon, did we pay anything up to 1,500? Well, anything up to 1,500, there's 1, 4, which is 5, another 8, 13. So in 13 occasions, or 13 weeks, we paid anything up to 1,500. So 1,500, 13 is about there. What about up to 2,000 in total? Well, everybody earning, every week where it was up to anything up to 2,000, we've got up to 13. Well, in 32 of the weeks, it was anything up to 2,000. So, whoops, 2,032 there. What about up to 2,500? Well, there's another 14. So in total, 46 weeks, we paid up to 2,500. So that takes us up to there. And finally, what about 3,000? Well, another 6. So, So in total, obviously, in 52 weeks, we were paying anything up to 3,000. And that is called an ogive. Now, it's not as immediately useful, and for that reason it's not quite as important. You'll see later there is a use I can put that to. But it does show us, I'll tell you when it's really useful, is if you were looking at how much people are paid, if this is how much people are paid, the steepness of it, you see you've got a lot, if these were, they were paid either 500, 1,000, 1,500 and so on, a lot of people are earning a very low salary, and then it suddenly shoots up. You know, people at the top end, whoops, suddenly earn an awful lot more. Anyway, that's histogram and an ogive. But now let's actually look at ways we can measure average. And I need to look at it twice, once with discrete variables, as I explained earlier, and once with continuous. And you will see on the next page, there are 3 averages you're expected to be aware of. The arithmetic mean, the median, or the mode. And to illustrate, look at example 2, which is this complaints business again. So the number of complaints was either 0, 1, 2, 3. And the frequency, how often there was 0, how often there was 1, and so on. 1 week there were no complaints, 6 weeks there was 1, 4 weeks there were 2, 2 weeks there were 3. In total, we looked at 13 weeks. Now, I want to know, on average, how many complaints are there per week? Well, the most obvious way, I think you should already know, if I ask you to work out the average of 3 numbers, 5, 6, and 8, if I said, what's the average? you add them together and divide by 3, because there are 3 numbers. Well, that's the most obvious average, and it's called the arithmetic mean. And I'm not sure it would be needed for the exam, but the standard symbol is X bar, X with a bar on top. And we're going to do that here. You see, with 13 observations, and we add them all together and divide by 13. So 0 once, and then 1, 1, 1, 1, 1 6 times, 2 4 times, 3 twice. You could list them all, add them together, divide by 13, and there is your average. However, rather than list them all, to say 0 and then 6 ones, 1, 2, 3, 4, 5, 6, and then 4 twos, 2, 2, 2, 2. Talking a bit silly. I just need to know what the total of all of them is. Well, on one occasion it was 0, so 0 times 1 is 1. Shit. 0, sorry. 6 occasions it was 1, so 6 ones, that adds up to 6. On 4 occasions it was 2, so 4 twos is 8. On 2 occasions it was 3, 2 threes, 6. Excuse me. And so the total of all of those 1 0, 6 ones, 4 twos, and so on, the total comes to 20. So that's the total of all the observations. There were 13 of them, and so the average, divide the total by the number 20 divided by 13, and the average comes to 1.54. So that's the average number of complaints, 1.54 complaints, the arithmetic mean. Now, a couple of things there. One is some people get very upset about rounding. It actually comes to 1.53846. In the exam, most things like this you would round to 2 decimal places. If they want different, it will be made clear in the question. Secondly, although I'm not sure you'd actually be required to work in symbols, if you want this as a formula, but I think that's awful. The observations, the number of errors, we use the symbol X. The frequency, the number of times each one happens, we use the symbol F. And so what have we done? To get the total of all 13 observations, we multiplied F times X. And then we added up. We added up the frequencies, and you should have seen this symbol before. Sigma F, sigma sum of. We added up all the observations, F times X, so sigma Fx. And therefore, the mean X bar is sigma Fx divided by sigma F. Now, as I say, to learn that as a formula, I personally think would be ridiculous. If you've understood me, you don't need a formula. However, that is the arithmetic mean, that on average there are 1.54 complaints. And that is the average. It's what we normally think of as the average. However, one problem, if you like, is that, of course, in no week were there actually 1.54 complaints. The complaints were either 0, 1, 2, 3. And also, the average takes no account of whether, how many are more than 1.54 and how many are less. And so a second measure, slightly less obvious, is what we call the median. the median. And the median, I'll put it in words first and then illustrate. It's the central observation when all the observations are arranged in order of magnitude. Now, what I mean by that, before we look at the actual example, suppose you just had 3 observations, 1, 4, 6. If I said what's the arithmetic mean, the average, you add them up and divide by 3. Which is going to be 5, 11 divided by 3 is 3.67 or something. The median, though, we say, well, if we arrange them in order, lowest to highest, 1, 4, 6, what's the value of the middle one? And of course, that's pretty obvious. There are 3 of them. The middle one is there, and the value is 4. So that's what we mean by the median. But let's do it on our example. Again, the number of complaints, 0, 1, 2, 3. The frequency, 1, 6, 4, 2 is 13. Well, imagine if we were to list all of them from lowest to highest. You know, there was 1 at 0, then there are 6 of 1, and then there are 4 of 2, and then there are 2 of 3. There are 13 observations, and we want the value of the middle one. Well, what's the middle one? The middle one, surely, is the 7th one, because 1, 2, 3, 4, 5, 6, 7. There are 6 below and 6 above, and so the middle one is the 7th. Or what we're after is the value of, well, rather than write them all down like that, it's all right, but suppose there were 50 of them, we'd be there all day. We say it's the n plus 1 over 2th observation. So here there are 13 observations, so 13 plus 1 over 2, we want the value of the 6th one if they were all listed in order of magnitude. Now some of you are going to be saying, oh, what happens if there were 14? Be patient, I'll come back to it. But we want the value of the 6th, the 7th, the 6th. The value of the 7th. What on earth is it doing there? We want the value of the 7th. Now, of course, we've already seen what I did there. You could list them all, but as I said, if there were 50 of them, that's going to be ridiculous. How can we get the value of the 7th? Well, by looking at the total. What I mean is, at 0, there was 1. When we move on to 1 observation, that's an x6, so a total of 7. So the 2nd, 3rd, 4th, 5th, 6th and 7th were 1. Another 4 were 2. So the 8th, 9th, 10th, 11th, the observation was 2. Another 2, 13, were 3. So the 12th and the 13th were 3. And now we can see straight away, what is the value of the 7th? Well, we've already said The second, third, fourth, fifth, sixth, seventh were 1, so the value of the seventh, the median, is 1. What would it have been if I'd wanted the value of the fifth? Well, the second, third, fourth, fifth, sixth, seventh are 1. The value of the fifth would be 1. What would be the value of the ninth? Well, the 8th, 9th, 10th, 11th are 2, so the value of the ninth would be 2. So, no problem. I did say, some of you might be thinking, oh, what happens if it was an odd number? Suppose there were 14 observations. Then we want the value of 15 divided by 2, the 7.5. Now, it becomes a bit silly here, and I don't think this would happen in the exam. But if I did want the value of the 7.5 observation, we know the 7th is 1. Oh, but the 8th, 8th, 9th, 10th, 11th, the 8th is 2. And so it does become a bit silly, but if you wanted the 7.5, you'd take halfway between the two, you'd take 1.5. So, think about that, but I hope not too much of a problem. Finally, though, I said you need to be aware of 3 measures of average. Add them up and divide by the number, the arithmetic mean, the median, the middle observation, so there are as many above as there are below. The last one, very easy, is the mode. The mode is the most frequently occurring observation. So we know how many weeks there were 0, 1, 2, 3 errors. Which is the most popular, the most common, the most frequently occurring? Well, the frequency, 1 at 0, 6 at 1, 4 at 2, 2 at 3. The most popular, the most common, the most frequently occurring, because it occurred 6 times, is 1. It's the most popular. That's a really, really easy one. Just in case somebody's worried, although I don't think it would happen in the exam, if we did have 2 the same, you know, if 6 had 1 error, 6 had 2 errors, well, we'd say there are 2 modes. We'd say there are 2 modes. The mode is 1 and 2. So no tricks there. But there we are. So those are 3 measures: mean, median, mode. And that example was discrete observations. I will pause now, otherwise the lecture gets too long. But in the next example, again, we'll work out the 3 different averages, but when it's continuous distribution, which is exactly the same principle. But just takes marginally longer. But I'll do that in the next bit of this lecture.